Hey everybody, it's Mr. Carr again. Today we're going to be talking about 12.6 circular and periodic functions. Okay, so when we look at this, we want to remember our trigonomic definitions. So when you first talked about trigonometry, you were taught the SOHCAHTOA idea, and then we talked about the definitions of sine, cosine, and tangent in terms of a right triangle. Okay, earlier we looked at definitions of sine, cosine, and tangent when a point is on a circle. Okay, so what we're looking at is this what's called that unit circle. As a reminder, a unit circle is a circle with a radius of 1. So with this in mind, we're going to adjust our definitions of sine, cosine, tangent just a little bit. Okay. So especially because our limits before were when we did our SOHCAHTOA, they had to be inside of a triangle. So because of that, we don't know in terms of let's go past the 90 degrees. What is, for example, sine or cosine of 120 degrees? Okay. So that's where the unit circle comes into play. If the terminal side of an angle in standard position intersects the unit circle at point P, which is at x comma y, then the cosine of theta is x and the sine of theta is y. Okay, so that's what so every time whatever this point is on the graph, okay, it's left so much and up so much. Those 2 points are going to be cosine and sine. So for example, let's look at theta as 120. This is about 120 right here. So 120, if I do the 120 minus the 90, that gives me 30 degrees. That's what this is right here is 30. So what I have, if I kind of draw my reference triangle, I actually have a 60-degree triangle. Now, again, with our reference triangles, that makes this 30. So I can do 1 and then, sorry, normally I would do 1, 2, and root 3. But let me just draw that real quick here. That didn't work. There. Okay, so with a 30, 60, 90, got 1, 2, and root 3, right? However, since our hypotenuse is the radius, and I'm saying that the radius is 1, okay, and a unit circle, no matter where we go, the radius is 1. I'm going to modify my reference triangle a little bit. Let's divide everything by 2. Okay, so this becomes a 1 now. This is now 1 over 2, and this is root 3 over 2. Now, when I do that, that means across the 60 is root 3 over 2. And across the 30 is 1 over 2. And then my radius stays at 1. So thinking about this, since we have, this is a point here, I can actually say what that point is. It is negative 1/2 and then a positive 3 over root 3 over 2. So that means when I'm looking at this as these points, if I said, what is the cosine of theta or cosine of 120, the cosine of 120 is just negative 1 over 2. Now that makes sense because if I did my original reference triangles, the cosine of 120 is related to the 60 here. Okay, so I take away that idea, the cosine is this 1/2 here over 1. Okay, or if I did my normal one, it would be the cosine of basically the 60 is 1 over this 2 here. But again, as we said before, this quadrant, cosine is negative. So that makes sense for cosine of 120. If I look at the sine of 120, that's in reference to the 60 degrees, that my reference triangle, sine is opposite of hypotenuse, and that comes out to root 3 over 2. So that's what we're saying as that kind of a shortcut. All the points that are on the unit circle are written as cosine theta, comma, sine theta, which means I can look at these points here as the same thing. Okay, so the cosine of 90 degrees is 0. The sine of 90 degrees is 1. Okay, the cosine of 180 degrees is negative 1, and the sine of 180 degrees is 0. So we're representing this on this unit circle as these points, this x and y values. That is what we're getting at here. So this one's a little bit straightforward. The terminal side of an angle theta in standard position intersects the unit circle at these 2 points, or the x and y, I should say. Find the cosine theta and sine theta. So again, it's just cosine theta and sine theta in that order. So the x value is the cosine and the y value is the sine. So cosine of theta is just root 7 over 4. Sine theta is 3 over 4. That's it. Okay, that's as straightforward as we can get. Now, if we do something a little bit different, for example, like this one, find the exact value of cosine of 690. This is where things get a little bit trickier with the whole idea that it's periodic. All trigonomic functions are periodic. This means that after a certain period, the outputs repeat. Okay, it's that whole idea of the unit circle again. If I go around is 360, another time is 720, and whoa, didn't mean to do that, but here's like 360, here's 720, and so on and so on. Okay, we're repeating those same positions on that unit circle. So we'll see a little bit different how the periodic function graphs, but for now, we need to find our standard position of 690 degrees. Okay, so that's what's going to help us. Now, if we do things in terms of radians, don't forget, 360 is the same as 2 pi radians. So maybe you do things in terms of pi instead of degrees. So let's do 690 real quick. Okay, so we're going to find, let's see here. So I know I can go around one time for sure. So if I do that, 690 minus 360, that is going to give me 330 degrees. Okay, so I know I'm going to go around 330 more. Kind of help with that idea. I know that 330 is pretty close to 360, so let's do that real quick. 360 minus 330, that's 30 degrees. So that is almost all the way around again, but it's going to be like this right here. Okay, so this will be my 30 degrees is the idea. So again, I can use my reference triangle here. So if I do, let's see here, I want to find that as a point that's on the graph. Okay, so if I do my 30, 60, 90, 30, 60, 90, it's 1, 2, and then root 3. Okay, so I can do this, divide everything by 2. So that becomes a 1 right there. So really what's happening with this triangle, my reference triangle, is I'm going to the right, root 3 over 2, and I'm going down 1/2. Okay, so what that means is the exact value of cosine of 690. Since 690 is in the same position as well, not 360, same position as 330, and I can create this triangle here, that point on the graph is going to be, I'm just going to do this actually. Make it a little bit easier when I draw my reference triangle over here. Okay, so again, this is 30 degrees. This point is going to be root 3 over 2, and then a negative 1 over 2. Okay, move to the right and down. So that means if I want the cosine of that, the cosine of 690 is just going to equal to root 3 over 2. Because remember, it's cosine theta, sine theta. And that's it. That's how I can kind of use that unit circle. So if you have the unit circle as a reference, this is very quick and easy. But for now, we're just going to practice drawing our reference triangles on the coordinate grid. Once we get it there, we have to just figure out what are my 2 points, and I can use this idea here with that to help set that up. Okay, so, and again, as a quick refresher, all students take calculus. Whoops, so the calculus part is going to be positive, and that's what we have here with our positive root 3 over 2. Okay, one more example we'll do together, and that's going to be the exact value of sine of negative 11 pi over 4. So again, we need to find our reference spot on here. So a negative 11 pi over 4 is going to go in the clockwise direction. So if I take, I'll actually go 11 pi over 4 minus 8 pi over 4, because that is a 1 full circle. We're left with 3 pi over 4. So what that means is I'm going to go around 1 time, going that direction. I'm going to go 3 pi over 4 more. So that's actually going to end up being right about here. Okay. So that's where that's the position I'm working with. So let me just redraw it so real quick. So with that 3 pi over 4, I'm actually creating the isosceles right triangle. It's a 45, 45, 90. Okay, so that's going to go right here is a negative 3 pi over 4. So I can do this as, if I do it as my reference triangle, I'll write this down real quick. Again, I want everything in terms of 1 for the hypotenuse, because that's what the radius is. So if I divide everything by root 2, oops, then I get, that's a 1. This is 1 over root 2, which is the same as root 2 over 2. And this is also root 2 over 2. So that is both of these sides, root 2 over 2, and then root 2 over 2. So that makes that point negative root 2 over 2 and negative root 2 over 2. Okay, so in that position, since I'm looking for sine, sine is the second version. So that means the sine of a negative 11 pi over 4 is just equal to a negative root 2 over 2. Okay, and that's it. That's our exact values there. Okay, so if you want to try this one on your own, well, this one's already kind of done, but you can kind of see it straightforward there. But try this one, the exact value of cosine 660 and the exact value of sine 9 pi over 4. Again, the goal here is to find those reference triangles on our unit circle before we make that. That's it for today. Take care, everyone. See you next time.